Welcome to the Deep Dive. This is your essential shortcut to understanding the biggest moves in tech. And today, November 2nd, we're zeroing in exclusively on a flood of AI updates that actually dropped yesterday, November 1st, 2025. You might think Saturday is a quiet day, but, well, not in the AI world, apparently.
Not at all. It was, something of a perfect storm. We saw major news on model performance, the sheer scale of infrastructure needed, and this really intense geopolitical maneuvering around governance. We've picked out 13 key developments from yesterday. Our goal, simple, cut through the noise, give you the organized deep dive you need. We'll break it down. Research, infrastructure, and policy.
Okay, let's unpack this then. We should probably start with the models and the research side. And the story that jumps out immediately is, well, it's this contrast, isn't it? Incredible speed and abstract thinking versus the stubborn difficulty of the physical world.
Absolutely. We saw three huge moves just in the multimodal space. That's AI handling images, video, text all together. First up, OpenAI in the US. They rolled out performance upgrades for their O3 Pro model.
Okay, O3 Pro. What's new there?
The focus was really on core capabilities. They hit new state-of-the-art SOTA benchmarks, specifically on reasoning and reliability. It shows, that the closed proprietary models are still pushing forward, consistently improving.
Right, but then Google's DeepMind, also US-based, dropped something pretty massive. Their Gemini models, Ultra, Pro, and Nano.
And the scale here is, well, it's striking. The Gemini suite set new SOTA performance on 30 out of 32 standard benchmarks.
30 out of 32.
Yeah, 30. That really cements their position, leveraging Google's, vast data and compute power to lead in these standardized tests for multimodal AI.
So that sounds like they just swept the field. But hang on, looking at item A3, it's not quite that simple, is it? The open source side is fighting back.
Exactly. Mistral, out of the EU, specifically France, released Pixtral Large.
And how did that stack up?
Well, here's the fascinating part. While Gemini took the overall crown across most benchmarks, Pixtral Large, which is an open weights model, actually outperforms closed models like GPT-4o and even Gemini on several key vision benchmarks.
So better at seeing, specifically.
Kind of. It raises a really interesting question. If Gemini is SOTA on 30 benchmarks, maybe those benchmarks lean more towards, say, language and reasoning. And that leaves room for a specialized open model like Pixtral to excel in pure visual processing. It tells us the race isn't just about one winner, it's also about finding these powerful niches.
You really nailed that disconnect. We've got these digital brains moving at light speed, but then we hit this physical reality check. Item A4, the Butterbench experiment from Andon Labs in the US. Tell us about that.
This is super important for anyone watching robotics. Researchers basically plugged a sophisticated large language model, an LLM, into a robot. They tested if it could take natural language instructions like find the butter in the fridge and spread it on this toast and actually do it.
Okay, so the LLM knows everything about butter, fridges, toast, kinematics. But could the robot actually make breakfast?
Not really. The robot scored below 40% accuracy on these simple embodiment tasks. 40%.
Wow, below 40.
It just highlights this massive stubborn gap. The LLMs are incredibly smart in the abstract, but they're trapped. The physical world needs real-time sensing, dealing with errors, fine motor skills, things that models train mainly on text and images they lack that grounding. The digital world is neat. The physical world is messy.
Okay, so they can't make breakfast yet, but they are changing how digital stuff gets made, right? There's an Adobe report, item A5, looking at German creatives.
Yeah, that's a huge indicator of enterprise adoption. The survey found 95% of German creatives are now using generative AI tools.
95%.
95. For things like design, motion graphics, visual content production, it shows that AI assistance is basically the standard workflow now in a major economy like Germany's. It really shows where the immediate payoff is, the digital domain, exactly where the robots are struggling.
And that scale isn't just happening in professional studios. Item A6, a Google Cloud case study on the Night Cafe AI art platform.
Right. That just underlines the massive scale. Night Cafe hit 25 million users running on Google Cloud. It demonstrates huge enterprise adoption and, crucially, the scalability for these creative AI tools. They're not niche anymore. They are absolutely mainstream.
So the digital world speeds up, the physical world lags behind. That feels like the core tension from the research side today.
I think that's exactly right. And it reinforces this idea that raw compute power, the infrastructure, is maybe the key bottleneck now, which leads us neatly into our next segment.
Right. Segment B. This is where, as you said, it gets really interesting. Strategic capital, the infrastructure race. If models were yesterday's battleground, Maybe infrastructure, the chips, the power, the data centers is today's strategic choke point.
And we're seeing governments betting big, I mean really big. The US and Japan announced a joint $550 billion AI infrastructure investment.
Whoa, hang on. Did you say 550 billion?
Billion with a B, $550 billion.
That's, context. That's like building the Panama Canal 10 times over just for AI infrastructure.
Pretty much. It's dedicated funding for shared power grids, data centers, manufacturing capabilities, using huge contractors like Bechtel, Kiewit. The scale is clearly meant to build a dominant position. It signals this shift, doesn't it? From just competing on software algorithms to aggressively securing the hardware and energy needed for the next generation of AI. It's explicitly geopolitical. Control the means of production.
And that massive US-Japan move seems to be prompting reactions elsewhere. Sovereign AI capabilities are becoming critical. Look at India, item B3.
Correct. The IndiaAI Mission just launched public infrastructure aimed squarely at supporting their own indigenous model development. They're providing access to over 10,000 GPUs. The goal is clearly self-sufficiency, fostering local innovation, making sure India can build AI tailored to its own needs, its own data, without total reliance on, say, US cloud providers.
And we're seeing a similar push in Europe. Item B4, the EU's AI Factories Initiative.
Yeah, the EU is also scaling up its supercomputing resources and trying to foster homegrown AI models. Importantly, this is happening under the framework of their new AI Act. So the goal is capacity, yes, but capacity that meets Europe's specific rigorous compliance and trust standards.
Okay, so massive government spending on infra. What about the private sector? The chip makers?
Yeah.
Item B2, Intel and Sambanova.
Right. Intel plans a $5 billion acquisition of Sambanova Systems.
$5 billion. Why Sambanova?
It looks like a classic vertical integration play, maybe a bit defensive too. Intel wants to optimize custom chips specifically for inference that's efficiently running the train models and build out a complete end-to-end AI stack, if you connect the dots. The huge public investments in the US, Japan, India, the EU, plus this Intel move, it all points to the same thing. The game is shifting. It's not just about having the smartest algorithm anymore. It's about controlling the physical capacity to train and deploy these powerful models globally.
Which logically brings us to governance. Segment C. With these huge investments and fast models, the race to set the rules is on. And it looks, well, deeply political and pretty fragmented.
That's the core question, isn't it? Who gets to define trustworthy AI for the world? We saw some major moves at the APEC summit in South Korea yesterday. China's President Xi Jinping proposed creating a World AI Cooperation Organization, WAICO, to be headquartered in Shanghai.
WAICO. Okay, that sounds significant. What's the angle?
It's a clear geopolitical maneuver. The idea is to counter U.S. influence by pushing for a multilateral approach. Frame AI as a public good, managed internationally. It directly challenges the sort of Western-centric model where rules often emerge from U.S. companies and standards bodies.
And China wasn't the only one making proposals at APEC. Mexico was active too, item C2.
Right. Mexico called for a regional AI regulation framework, specifically for the Asia-Pacific, addressing regional risks and, interestingly, demographic challenges. It just shows, even regionally, there's no single consensus on how to govern this technology.
So lots of proposals, but Europe is actually putting hard law in place. Item C3, the EU AI Office, and the AI Act implementation.
Exactly. This isn't just talk. The European AI Office is now fully established. It's supervising the enforcement of the AI Act, coordinating guidelines, setting benchmarks. This is the world's first comprehensive legal framework for AI with harmonized rules. And why this matters to you, the listener, is crucial. If you deploy AI systems anywhere near Europe, these are increasingly the global standards you'll be judged against, particularly regarding systemic risks in large models. The EU is prioritizing safety, trust, compliance.
Okay. And finally, on the governance front, item C4, something from the U.S. National Institute of Standards and Technology, NIST.
Yes, NIST released an updated taxonomy and terminology for adversarial machine learning.
Adversarial ML, so attacks on AI systems.
Precisely. NIST sets standards in the U.S. This update focuses on critical risk management. As the models get smarter, the ways to attack them get more sophisticated too. This new taxonomy gives engineers and risk managers the specific language needed to identify, classify, and hopefully mitigate these vulnerabilities. It's essential for deploying models like O3 Pro and Gemini safely.
Right. We have covered a lot of ground today, from robots failing with butter to $500 billion investments. Before we wrap, let's pull out a couple of specific things you, listeners, can maybe look into or use based on today's news.
Okay, two quick recommendations. First, take a cue from those German creatives, item A5. Seriously, consider how generative AI tools could fit into your own workflow. That 95% adoption rate is staggering. Think about the efficiency gains, especially if you work with any kind of visual content, media, marketing.
Good point. And the second,
If you're involved in deploying AI models or you manage technical risk in your organization, definitely check out the new NIST adversarial ML taxonomy update we just mentioned, item C4. Think of it as a vital resource for thinking critically about vulnerabilities in your systems before they get exploited.
excellent. Okay, let's do the numbers of the day. What stood out?
Number one has to be $550 billion, that joint U.S.-Japan investment in AI infrastructure. That single number just defines the sheer scale of the geopolitical race for hardware dominance.
Hard to argue with that one. And the second number?
Let's go with 30 out of 32, the number of benchmarks Google's Gemini suite achieves state-of-the-art on. It just highlights the incredible speed of progress, at least in abstract intelligence within these closed-source models.
$550 billion for the infrastructure, 30 out of 32 for the digital brain's performance.
So let's step back. What does this all really mean? You have these incredibly powerful AI models, the digital minds like Gemini and O3 Pro, setting world records in complex reasoning. But then you have a physical robot using one of these advanced LLMs that still can't reliably perform a simple task, like spreading butter scoring below 40% accuracy.
Right. We're pouring $500 billion into making the digital brain smarter, but the connection to the physical body, to the real world, it's still incredibly weak.
It forces you to ask, doesn't it? Which problem is actually more valuable for us to solve right now? Pushing the absolute limits of abstract, disembodied intelligence, or tackling the frustrating, messy, practical incompetence that stops AI from truly operating and helping us in the physical world around us?
A fundamental question to think about. That's your deep dive for today. We'll see you next time.